All right, number 12, we want to solve this rational expression. And first, we're going to start out by finding critical values that make the denominator 0. And then we'll find out what values make the whole expression 0. So we have x minus 3 divided by x minus 5 is greater than x divided by x plus 1. And we're going to find out what makes the bottom 0 by setting the bottom equal to 0. So x minus 5 equals 0 and x plus 1 equals 0. Or rather, I should say not equal 0 because we cannot divide by 0. That will give us x equals 5, and this will give us x equals -1, or let me say not equal. Okay, so these are two critical values. And then we're going to find out what makes the whole thing 0. And then what I'm going to do is I'm going to move this over to the other side. So I'm going to do x minus 3 divided by x minus 5. And then you subtract this term to move it over, so there'll be a minus x over x plus 1. And that is greater than 0. So we're looking for the values that make this expression greater than 0. Another way of saying that is positive. Numbers that are greater than 0 are positive. Now, you can combine like terms. When you got fractions, you got to get a common denominator. And instead of dealing with the fractions, the easier way to do this would just be to cross multiply and then solve it that way, and you would still get the same value. So that's what we're going to do. We're going to multiply x plus 1 across, and we're going to multiply x minus 5 across. So that means the x minus 3 is going to get multiplied with the x plus 1. And then going across, I'm just going to put equal for now. Going across, x minus 5 is going to get multiplied with x. All right, so we're going to FOIL x times x will give us x squared. X times 1 will give us a positive x. Negative 3 times x minus 3x, and negative 3 times 1 will give us a negative 3. And then on the other side, distribute the x to both terms. It's going to give us x squared minus 5x. Combine like terms in the middle. That will give us x squared minus 2x minus 3 equals our x squared minus 5x. All right, going to combine like terms. We're going to move the x squared minus x squared from both sides. That will cancel, leaving us with a negative 2x minus 3 equals negative 5x. And then we can move the 2x over to combine it. And that will cancel over here, bring down the negative 3. Running out of room, bring down negative 3 equals, and that will give us a negative 3x. All right, divide by negative 3 on both sides. And that will give us positive 1 is equal to x. So that's our other critical value. So now that we have all of our critical values, I'm just going to make a little number line over here. We're going to find out which ones give us positive. So negative infinity, positive infinity, and the values we have are negative 1, positive 1, and positive 5. And I'm going to put a circle above. I cannot be equal to those no matter what. And we're going to test some values. So let's just say negative 2, between negative 1 and positive 1, 0. 1 and 5, let's just do 4. And after 5, we can do 6. So I'm going to graph this function. I'm going to type it in like this. And we're going to see which one gives us positive. Now, since these are all whole numbers, I'm just going to go look at the table instead of typing them all in. y equal, gotta turn it on, y equal alpha, y equal, enter just to make the fraction. And we're going to do x minus 3, and then x minus 5, and then minus, make another fraction bar, alpha, y equal, enter, and then x over x plus 1. I'm going to graph. And then I'm going to do second graph to see the table. And I'm going to be looking for -2, so I got to arrow up. That gives me a negative. And I'm looking for a positive, so this is incorrect. I don't want that section. Now I'm going to look at 0. Well, actually 0 is right here. That gives me a positive value, which is what we want. So -1 to 1 is part of my solution. Okay, and then we're going to look at 4, which gives me a negative. We don't want the negative part. And then we're going to look at 6. And it comes out a positive value here. So that's what we want. So I have -1 to 1 union 5 to infinity. -1 to 1 union 5 to infinity.